Okay, we've looked at the electric force on a charged particle, long ago. We've looked more recently at the magnetic force on a moving charged particle due to an external magnetic field. But suppose that instead of that moving charged particle, what I'm actually looking at is some tiny section, whoops, of a wire. And I want to find out, okay, I've got some piece of what, some chunk of a wire and that is inside a magnetic field. What's the force on that? Well, in the same way that, okay, if I look at the magnetic field on or the magnetic force on a moving point, then, that's related to the charge and the velocity. Well, we've looked at it in this sense before. I could say, well, the magnetic force on a piece of wire is equal to, okay, that some differential piece of charge, dq, in whatever charge is located in that tiny segment, times the velocity, dx over dt, crossed onto the magnetic field. Well, if I rewrite this, like so, or perhaps I'll use S, so my X and my cross look different. Then what I've got, or actually I believe the textbook uses L, the delta Q over delta T is the current. So the magnetic force on a current carrying piece of wire is equal to I times delta L cross B. Similar in that structure.